Okay, welcome back from March break, everybody. As you may have noticed, I am away for this week, away on the BC trip with the school. So I'm trying something new. I'm going to try and record myself teaching this lesson like I would normally at the front of the class. And then you can watch it, pause, rewind as you please, follow through with the notes, and then work on the practice questions for homework. So hopefully this works. I look forward to your feedback. All right, before the break, we started learning about solution chemistry. We did a lesson on net ionic equations and we looked at precipitate reactions. And today we're going to start looking at types of solutions and something called solubility curves. So a solution, as hopefully you may remember, is a mixture of more than one substance. So in this case, a solution is a homogeneous, which means that it looks like only one thing. So we can add a little note that says that looks like only one thing. So for example, something like tea is a homogeneous mixture because you can't see the tea particles in the water. So a homogeneous mixture of two or more substances. The two parts of a solution are called the solvent and the solute. You can have multiple solutes in a solvent, but there's only ever one solvent. The solvent is the component present in the greatest amount. So the component or substance present in the greatest amount. So for example, in tea, that would be water. In the air, it would be nitrogen. If you are making a solution of calcium chloride, like we did in the lab before the break, it would be water again. The solute is the component, or it could be components, that is dissolved in the solvent. So in air, for example, the solvent is nitrogen. The solutes would be things like oxygen, carbon dioxide, argon gas, helium gas, and a few other tiny things. In tea, the solute would be the tea. In calcium chloride solution, it would be the calcium chloride. Recall that when we talk about solutions in reaction equations, we use the symbol aqueous, AQ, to show that something's aqueous. And that means that it is dissolved in water. All right, there are three types of solutions: unsaturated, saturated, and supersaturated. You might have heard of unsaturated and saturated things before, possibly in biology when we talk about fat chains. But in this case, it has to do with how much solute is dissolved in the solvent. So we're going to look at each one of these and give a definition and a little sketch to represent what's going on. So an unsaturated solution is a solution, that could dissolve more solute. So for example, if you put some salt in water, but you only put a little bit in and you stir it and it dissolves, and you put more in and it continues to dissolve, that would be an example of an unsaturated solution. So let's draw a little beaker here. Pardon my artistic skills. Give it some graduations. Okay, so there's my beaker. And we'll add some water in it. So we'll say it's about that full. And we're gonna add some sodium chloride to it. So we'll have a little scoopula here with some sodium chloride. We'll label that NaCl. Let's say we have some NaCl dissolved in the solution already. It would look like ions, so it'd be Ca or Cl minus and Na plus, because our reaction here is NaCl solid. Dissolving in water would be Na plus and Cl minus, and those would be aqueous. Remember, when you have a reaction equation, if it has an ion, it's assumed aqueous. You don't have to write it down. So if we were to add more of this salt to our solution, if it was unsaturated, then it would continue to dissolve. So the Na pluses and the Cl minuses would continue to be there, and there would be no salt sitting at the bottom of the beaker. It would all dissolve. Sometimes it takes a little bit of stirring or something like that, but it will go. So as more is added, it continues to dissolve. We'll make a little note here. As more is added, it continues to dissolve. And that's an unsaturated solution. For a saturated solution, now we have a solution that cannot dissolve any more solute. So it's full, it's at capacity. So a solution that cannot dissolve more solute. So in our beaker here, in our graduations, we have our water. And again, we'll stick with our salt example. So we've got Na plus Cl minus ions in here because we've added salt to the water. But even though we talk about solubility as sort of a yes or no when we did our unit on the bonding and matter stuff, and we talked about covalent bonds versus polar covalent versus molecular, and we talked about whether something would dissolve in water or not. Most ionic compounds do have high solubility in comparison to molecular compounds, but they are all a little bit different. So sodium chloride does have a pretty high solubility. So we would dissolve some in there, and now if we were to add more to this solution, more solid sodium chloride, it would fall in and then it would sit at the bottom. So if the solution is saturated, no more can dissolve, so it would just sit and settle at the bottom. We'll make a note here. As more sodium chloride, NaCl solid, is added, it sinks to the bottom because the solution is already holding all the ions it can. So at that particular temperature, there's no more sodium chloride that can be added to the solution to dissolve. But as a lot of you might know, when you add something to water and you stir it and it dissolves, if it doesn't all dissolve, you can heat it up to get more to dissolve. So you can add more sugar, more salt, more tea, whatever it may be. More of it will be able to dissolve in the solution if you increase the temperature. And when that happens, when you increase the temperature, you can have more solute dissolve in the solvent, and then when you cool it back down, it now becomes what's called a supersaturated solution. So a supersaturated solution is a solution that contains more dissolved solute than a saturated solution at the same temperature. Okay, so this occurs when you cool down a saturated solution from a higher temperature to a lower temperature. Occurs when a saturated solution cools. So we'll draw our beaker again over here. They're just getting worse and worse. Oh well. All right, there's our water. And so now what we would draw is more, let's assume these are all the same temperature, and we would have more ions dissolved in the water than they were in the saturated solution. So let's say all of these are at room temperature, so 22-ish degrees Celsius. So we'll just make a little note here. 20 degrees Celsius, 20 degrees Celsius, 20 degrees Celsius. So to get the solution to happen, we would have had to heat up this water to maybe 30 degrees Celsius or anything like that, have the salt dissolve, and then slowly cool it back down to 20 degrees Celsius. And that's when it becomes a saturated solution, because we would have more ions. So we can draw our ions in, Na plus and Cl minuses, and we want to draw in more ions to this picture than we had in the previous picture. Okay, so here we'll make our little note here. More sodium chloride is dissolved than in a saturated solution. So these are our three types of solutions: unsaturated, saturated, and supersaturated. Once I get back from BC, we will do a lab looking at these solutions.